Welcome to Cookie's Maths and Science Hub. Today we'll be looking at ions and isotopes. Both the topics we're exploring today, ions and isotopes, are heavily related to the atom. So, in case you haven't watched our Structure of the Atom video, we're just going to cover it quickly now, just the basics to make sure you fully understand what we're talking about before we go into the next steps. So here's a picture of our atom. In the center of the atom is the nucleus, which contains the protons and the neutrons. And then around it in distinct energy levels are the electrons. Just recall that there are three subatomic particles, so those protons, neutrons, and electrons. The proton is positively charged and has a mass of 1 atomic mass unit. The neutron is neutral and has a mass of 1 atomic mass unit. And the electron is negative and has a mass of 0.00054 atomic mass units, or a very, very small mass that's pretty much negligible. The important thing to consider when talking about ions are protons and electrons. So let's talk a little bit more about electrons. Electrons exist in distinct energy levels surrounding the nucleus, or the center of our atom, known as electron shells. The first shell will always have 2 electrons, or up to 2 electrons. Obviously it could have less than 2. And shells 2 and 3 have 8 electrons. On the right here we have argon, which has in total 18 electrons. So you see its first shell has 2, its second shell has 8, and its third shell has 8. Once you start to get into the higher shells, those numbers get a little bit more tricky, but we're only going to focus on the atoms up to 20 on the periodic table, meaning they only have 20 electrons, or 3 shells for the most part. When it comes to ions, the most important shell is what we call the valence shell, and the electrons in this shell known as the valence electrons. These are electrons in the outermost shell of an atom. Now that might be the first shell, the second shell, or the third shell, just depending on how many electrons the atom has. All atoms, regardless of the number of shells, want to have that full outer, or that full valence shell. They want to make sure that outer shell is full. So that might be 8 in shells 2 and 3, or 2 in shell 1, sorry, my apologies. If they have less than 4 in their outer shell, they will lose electrons to achieve this. This is common on the left-hand side of the periodic table, or the metals in the periodic table. If they have more than 4 in their outer shell, they will gain electrons to achieve this. This is common on the right-hand side of the periodic table, so the non-metals on the periodic table. Our example we used before, argon, has 8 valence electrons already. As such, it already has a full outer shell and doesn't need to achieve or gain or lose electrons to achieve its full outer shell. Once we start to lose or gain electrons, we end up with what's known as a charged atom, or charged particles. The standard charge of an atom is 0. It's neutral, as it has the same number of protons and electrons. So if we look to the right here, we can see that lithium and oxygen are neutral in their standard form. Lithium has 3 protons, and it has 3 electrons. Therefore, its overall charge is positive 3 plus that negative 3, which gives us an overall charge of 0. Oxygen, on the other hand, has 8 protons, 8 electrons. Therefore, its overall charge is 0 because positive 8 subtract 8 gives an overall charge of 0. However, as we have established, atoms want to lose or gain electrons to have a full outer shell, and this will affect the overall charge of the atom. Remember, in this case, and when we talk about these sort of particles, we don't need to worry about neutrons, as they don't affect the overall charge of the atom, as they are neutral themselves. Looking again at lithium, it has 1 in its valence shell, or its outer shell. That means, because we know it has less than 4, and it's going to want to fill that shell, it's going to get rid of that electron. So, if we were to redraw lithium, we now have lithium with 3 protons and 2 electrons, because its outer shell is full, which means its overall charge is positive 3 plus negative 2 from the 2 electrons, so its overall charge is plus 1, or 1 plus. Therefore, we call that lithium 1 plus, as we indicate its overall charge based on the number of protons and electrons present. We can do the same for oxygen. Oxygen has 6 valence electrons, so we know it's going to gain electrons to fill that outer shell. So if we were to draw that out, we now see oxygen has 8 protons and 10 electrons, in total that is, including that first inner shell with 2. So now its overall charge is positive 8 plus negative 10, which equals negative 2, or 2 negative. Therefore, we would label that as oxygen 2 negative. to indicate that charge on that atom. These charged atoms and particles are what we refer to as ions, one of the concepts we're exploring in today's video. Positively charged ions, such as our metals, and in this example that we used lithium, are called cations. Negatively charged ions are called anions, the example in this case being our oxygen. Ions are essential to a specific form of bonding known as ionic bonding, which we'll cover in another video later on. Now, it's important to remember these two terms, cations and anions, and an easy way that I often teach is that cations are positive because you can relate it to cat, and I always say they're positive. Sometimes it sounds a little silly, I know, but these little mnemonic terms can help you remember these ideas and help apply them in your understanding. Whilst ions deal with protons and electrons, isotopes deal with the number of neutrons and protons. When we're looking at the mass of an atom, we can easily determine it from the number of protons and neutrons present, just simply by adding them together, as each one represents one atomic mass unit. As I mentioned earlier, electrons have a very small mass, meaning it isn't usually used in these calculations. If two atoms have the same number of protons and electrons, but different neutrons, they are considered isotopes of the same element. So we remember that protons determine which element we have. Neutrons only affect the mass, meaning that if we have the same number of protons, but differing neutrons, we're going to have isotopes of the same element, because they have different masses. The example on the right shows this. We have lithium with 3 protons and 4 neutrons, so it's lithium 7, and we refer to that as lithium 7 because its mass is 7. And then we have lithium with 3 protons and 3 neutrons, so it's lithium 6 because it has that mass of 6. You'll see both have the same number of protons and electrons because they are the same element. They just have a different number of neutrons affecting the mass in this case. Isotopes of an element have the same electron configuration and similar chemical properties, but they can have different physical properties. Now, when you look at the periodic table, and we look at lithium, for example, continuing with that example, you'll see it says lithium 6.94. Now, we can't really get that from just adding, obviously, 1 plus 1 plus 1 from our proton and neutron masses. This is because on the periodic table, it is reported as what's known as the relative atomic mass. So, assuming we just have those two isotopes, so we've got lithium 7 and lithium 6, what this means is, in nature and in our scientific studies, we've determined that lithium 7 is possibly 95 or higher % more likely to occur. We then do a little bit of maths, and effectively, given that lithium 6 is such a small percentage, our average mass, or our relative atomic mass, is 6.94. This indicates that the lithium 7 is a far more common type of the lithium, a far more common isotope of the lithium within nature. So this is what we call relative atomic mass, and it's given in the periodic table because it's calculated for all naturally occurring isotopes of each element. It's often also referred to as the atomic weight. Thanks for watching. Hopefully now you have a really good basic understanding of ions and isotopes, and you'll be able to use this video and this understanding in your further studies into these two concepts. Be sure to like, share, and subscribe this video, and stick around and watch some other videos exploring science and mathematics. Hope to see you back again soon.